Before we dive into the Defender demo, which, as David said, we're going to go through every part of it and we'll have time for questions. I'm just going to do a little bit of an overview intro here, and I'll share my screen. So one of the things we're talking about here today, and we kind of cover in the various workshops that David mentioned, is the idea of DevSecOps for Ethereum projects, and as we look at other platforms as well. And the idea is to streamline the connection between development, operations, and put security in every step of what we do. And the goal is to be able to develop and ship our projects faster, but following good patterns and best practices, and hopefully avoiding some of the shortcuts that before now many project teams had to take shortcuts in order to meet speed, and sometimes the shortcuts end up shooting us in the foot where we have security issues or unforeseen problems, as we've seen in the space. So we have two product areas that we work on at OpenZeppelin. One is OpenZeppelin Contracts, which is on the kind of development building side. And that's where we have taken best practices and security patterns, and we provide you a set of Solidity libraries you can build from. You may be familiar with those already. And then what we're going to show you today is on the operations side. As you'll see with Defender, Defender gives you tools, infrastructure, capabilities that hopefully will help you from the very beginning build faster and avoid having to build some of your own tools or infrastructure yourselves. But very importantly, then, once you release, it's going to help you be more secure. It's going to help you administer your smart contracts in a following best practices and very efficiently. So if you do end up in a situation where you have an emergency and you need to kind of invoke emergency response, OpenZeppelin Defender can help with that. And it's going to give you extra reliability too. And I think as we show you the features today, it'll become clear how some of those capabilities help you be more reliable without having to do all the extra work yourself. So that's what we have. And one of the places I'll refer you to before we get started is everything we cover today you'll be able to find at docs.openzeppelin.com around Defender. But if you're not familiar with contracts or all the upgrade proxy contracts we also have for you to build from, there's great learning materials here, as well as some others that we'll refer to you to later, so you can find out all about contracts here at our docs site. So with that intro, I'm going to turn it over to Paula, and we'll provide you a demo for OpenZeppelin Defender.
Thank you, Jonathan. So the plan for today is to go through a contract that we have already deployed on the Ringby network and show you a few capabilities of this contract and how we can manage them using OpenZeppelin Defender. This contract acts as a vault in that it collects deposits from different users and takes a fee out of every deposit. So during the session today, the plan will be to adjust some of the parameters of this contract, such as tweaking the fee that's collected out of every deposit, moving the funds collected on a regular basis to a different, more secure wallet, or monitoring the contract to see if there are any whales depositing funds here and react accordingly. And the idea is that for every single one of these tasks, we'll be using a different part of Defender. So we're going to start with Defender Admin. Defender Admin is an interface for securely running administrative transactions on your contracts using multi-signature wallets. The idea is that if you have any kind of sensitive or only owner, let's say, kind of functions that you need to call in your contract, such as in this case, let's say adjusting the fee of the contract, you probably don't want to have a single key having the capabilities to run that transaction. Once you go into production, we strongly recommend that at the very least you deploy a multi-signature wallet to take care of that. And Defender admin acts as an interface to simplifying the process of running any kind of sysadmin transactions through these multi-signature wallets. We recommend using either Gnosis Safe or the legacy Gnosis multi-signature wallet. Defender admin supports both. And here, Defender admin just acts as an interface. It doesn't require you granting any kind of rights to Defender for managing your contracts. It's just going to be a layer on top of the multi-signature wallet, so you can more easily execute, review, and monitor these transactions. So let's see how this looks like. This is, I'm going to increase the zoom a little bit. This is the view from Defender admin. I have already added a couple of contracts already. I'm going to go ahead and add the vault contract that I have deployed on RinkBuy. Adding a contract is just for letting Defender know that we're going to run some operations on it. Again, there's no transfer of ownership involved here. I'm going to lift the vault contract from my address book. Throughout Defender, whenever you need to enter an address, you can pick from an address book that's shared across your entire team. You can provide friendly names for any address you enter, and Defender will remember that, and you can use that as a sort of registry of addresses. Once you pick an address in a network, Defender will automatically pull in the ABI if the contract has been verified on Etherscan or Sourcify. It's going to automatically detect a couple of features. In this case, it's detecting that this contract is upgradable using a particular upgradability pattern that we provide, and also that it's possible, meaning that there are functions that allow us to send an emergency stop to the contract. I'm going to go ahead and add it. You'll see there are a couple of proposals from previous iterations working with this contract. But what we're going to do is create a new action proposal. A proposal is what we call any kind of change, any kind of transaction that we want to send to the contract that may go through a multi-signature wallet. So let's start with an admin action, which is the most generic kind of action you can send. So what you can do via an admin action is choose any public function on the contract that you want to call, choose the parameters, and choose which multi-signature wallet to route this transaction through. So in this case, we're going to adjust the fee. Here we can see that the fee of this contract is currently set at 20%. We're going to set it at 15. We're going to run this through a Gnosis Safe that we had previously deployed and appointed as the owner of this contract. And we're going to provide some information for other team members that are going to come here and review this proposal before approving it. So we're going to say that we're adjusting the fee to 15% because 20% was too high, something like that. The idea here is to provide as much information as you can. So when other team members come here into Defender and see that there is a proposal awaiting approval, they can understand what's the rationale behind that and decide whether they want to approve it or not. So what we're seeing now is the proposal review page. And this information can be seen by any team member of yours within Defender. When you access Defender, you can choose to invite as many collaborators from your team as you want, and they all have access to the same information as you do. In particular, they have access to any admin proposals that you have created that you want them to approve. So here we can see all the title and description that we have set up, which contract is being affected, which multisig we are using, which function we're calling, even the hex date of the transaction that will be sent, and we can approve it directly from here. Approving is just a matter of signing a message using one of the private keys that has rights over this multi-signature wallet. This is a 2 out of 3 wallet, so we're requiring at least 2 approvals. And what would typically happen here is that the full team member would come along and sign, but here I'm just going to switch to a different MetaMask account and hit approve and execute. So here, oops, sorry. What's actually happening is I'm sending the last approval and the actual execution transaction for setting the fee to 15%. And so this should be pending mining, and this is a transaction sent to the Gnosis safe that's ultimately going to change the fee to a different value. All this information is not locked within Defender. We also push all this information to a Gnosis safe transaction service. So if you have any team members that use this UI instead of Defender, they can also see what's going on here and can confirm and cancel accordingly. The Gnosis safe UI is usually a couple of blocks behind. That's why you still see that there's only one approval. But all information from Defender is pushed here as well. There it goes. Okay, but the idea is that besides calling generic functions in your contracts, you also have a bunch of prepackaged actions. So for instance, you can pause your contract easily with a single click. So you just provide some feedback on why you're pausing the contract, and you can immediately create a pause proposal that can go directly to the contract, or again, through a multi-signature wallet that can be reviewed by your team members. So this way you can very quickly jump into Defender and choose to pause your contract right away if you suspect a hack or any kind of foul play. And the other kind of prepackaged action we have is an upgrades. So if your contract is upgradable, you can very easily change its implementation address. You just choose a new implementation. Again, you provide information as to why you're performing the upgrade, and Defender will take care of packaging the transaction that goes through a multisig, through the proxy administrator, to the proxy contract, and ultimately performs the upgrade. Now, given that upgrading a contract is usually happens part in development, part during operations, because you actually need to develop and implement the new contract, we have a couple of plugins of NPM packages that you can use for simplifying this process. So this is let me zoom in a little bit. This is the Vault contract that we're currently working with. Let's say I set up a new version 3 of the Vault contract, which just changes the version identifier for the sake of it. We provide a plugin for Hardhat called Hardhat Defender that also uses our upgradability, the OpenZeppelin upgradability plugins. And you can use it for, in a single line, requesting to deploy a new implementation contract corresponding to the one you have just written. This will validate that the contract is upgradable, that the current implementation that the current instance can be safely upgraded to its new implementation, that the storage layout is compatible. It will deploy the implementation contract, and it will instantly create a proposal within Defender for this upgrade. So I'm going to go ahead and run this script. So behind the scenes, this is using my local development private key for deploying the implementation contract. But then it tells Defender, hey, I want to upgrade this instance to the new implementation. And that creates a proposal that needs to go through the approval of all the multi-sig signers within Defender. So if we go back to Defender now, let's cancel this upgrade proposal here. And we see here we see that we have just created an upgrade proposal. This is the one we created via API. And again, this is once again another action proposal, in which case we see that we're upgrading the Vault contract to a new implementation. Again, going through the same multisig, and we get a brief description why this is happening. We can also provide further information via the API. And again, this goes onto the same flow where all the different admins can review the proposal. We're working to add more kind of prepackaged actions, such as managing access control and different roles of the contract. And we're also working on different integrations for making this more transparent to your community. We're working with the Snapshot project, so you can get information from Snapshot in here and vice versa. We're also constantly working on adding support for more networks. Today we support Mainnet, XDAI, and Fuse, plus a bunch of corresponding testnets. And we're working for adding support for the Binance chain, the Phantom network, and also Moonbeam. And if you have any other kind of EVM compatible sidechains that you're interested in, just let us know and we can add support for them as well. Okay, that's it for admin. I'm not sure if we have any questions so far before we move on to the next component. Oh, by the way, on admin, we're also working on adding support for time locks. So you can enforce a delay between the time an action proposal is proposed and can be actually executed, which works both for security purposes, also for transparency to your community. And we're also working on batching. So you can create a proposal that has many different actions that can affect several different contracts. And you just need one round of signatures over that. And we take care of routing that to the appropriate contracts without you having to sign each transaction individually. Okay, if we don't have any questions so far, I'm going to move ahead on to the next component, which is relayer. Moving on to relayers. Let's say that another thing we want to do on the Vault contract is move the funds that we have collected out of the fees that we have been collecting from users to a separate location, to a secure wallet. For that, we have a method called sweep that we can call at any time, and we'll take care of moving the funds elsewhere. Now, we don't want to be manually calling that from our MetaMask. We want to automate that process. And for that, we need a hot wallet that we can use for sending those transactions on a regular basis. What we found when working on the definitions for Defender with several teams is that properly securing those hot wallets is no easy task. Many teams end up with plain text files holding the private keys on shared servers or locations that can be very easily compromised. And if sweep were a public method, then it's fine because only the funds used to pay for gas are at risk with the keys compromised. But if sweep is a method that has some sort of rights over the contract, then you want to make sure that that key is properly secured. So with that in mind, we built relayers. Relayers is infrastructure for securely hosting your private keys and simplifying the process of sending transactions. A relay on the RingBy network. Let's call it RingBy 10. I have lost track of how many relayers I have created on RingBy by now. And behind the scenes, Defender is going to create a private key in a secure key vault that's just assigned for you and your team that can only be used from this relayer. And we make sure that that private key never leaves the key vault, not even for signing transactions. All transactions are signed within the security of the vault. Now, when you want to use this key for sending transactions, what we do is we generate an API key and secret that you can use for authenticating in Defender via API and sending the request for a transaction to be signed and sent by Defender. For quick and dirty transactions, what you can do is just come here to the UI, pick an address that you want to interact with. Let's say that we want to run a deposit or something and send some funds. And you can just send the transaction from the address of the relayer right here from the UI. But this is meant just to be a temporary setting so that you can play around with your relayer if you want to. The idea is that for you to interact with your relayer, we expose an HTTP API that you can use so that your scripts can communicate with the relayer and send requests for sending transactions. So from your code, what you can do to easily do this, you can use an NPM package that we have developed. It's called Defender Relay Client. You can use it either standalone or together with Ethers.js or Web3.js. Here, I'm using an Ethers.js script. And in order to integrate it in your code, the only thing you need to do is create a new Defender Relay provider and signer using the credentials, the API key and secret that Defender generated for you. And by the way, this API key and secret, you can generate as many as you want, and you can delete all ones, you can rotate them as much as you need. And all the while, Defender will preserve the same Ethereum address because this corresponds to the same private key that, again, is only allocated for your usage. And so once you have set up a Defender Relay Provider as signer, you can use them in your Ethers contract instance. And from now on here, this is vanilla Ethers.js code. And the thing is that whenever you send a transaction, for instance, here I'm sending contract.sweep, this takes care of sending the sweep transaction. I'm only doing it if the fees collected are greater than a certain threshold. Instead of sending the transaction here from my machine, this is going to send a request to Defender Relay to sign the transaction and broadcast it. And Defender will also take care of nonce management to make sure that if I'm sending transactions from multiple sources, nonces will be atomically increased. It will also take care of determining the best gas price for sending this transaction based on the speed I choose. So we're checking 5 different gas price oracles, and from them determining what's the best gas price for the speed you have chosen given the current network congestion. It's going to send the transaction with your private key hosted on the secure key vault. It's going to broadcast the transaction via multiple network providers. So if, let's say, Infura is down, we make sure that your transaction still makes it on chain. And after sending a transaction, Defender Relay will keep monitoring it to make sure it gets mined. And if it doesn't, it will resend it with increased gas price in case there's high network congestion to make sure it properly gets mined. So you don't have to worry about monitoring it and resending. That's all handled on Defender side. The only thing you need to do is just send the transaction and Defender takes care of everything. So with this, you don't need any custom relay infrastructure. You don't need to worry about securely hosting your private keys. That's all handled on Defender. Now, given that this is something that you, in the case of sweep, this is something that you probably want to run on a recurring basis. Let's say every half an hour or so, you want to check if there are enough funds to move. What we did is we added another component to Defender, which is autotasks. And autotasks are serverless functions. Think of them as JavaScript, small JavaScript snippets that are tightly integrated with relayers that can run arbitrary logic and can be triggered either on a schedule basis or by a public webhook. And here you can set up whatever logic you want for deciding to send whatever transactions you want to your contracts. So for instance, I'm going to go to autotasks and bring up the sweep tokens autotask that I have already set up. And here, the code I have is pretty much the same I just showed you on the IDE. It uses the Defender Relay Signer and provider for checking the current funds that have been collected by the vault contract. And if they are greater, if the current funds are greater than the threshold that we decide, then we send the transaction for sweeping. And the thing here is that we don't need to copy paste any kind of API keys and secrets. What we can do is when we configure the autotask, we can choose to wire this to a relayer. So here we got a list of all our relayers. And so whenever your code from the autotask chooses to send a transaction, it will be sent using this particular relayer without you needing to provide any kind of API keys and secrets. Here I've set up this autotask so it runs on a recurring basis every couple of hours. You can also choose to set up a public webhook for this so that you can get a public URL that you can hit and can react to that within your code. You can use that for integration with third-party services, for implementing gasless transactions by exposing that URL on your UI, or whatever other kind of criteria you want for triggering your autotasks. You can also manually run them at any time so you can easily debug them. And again, from the autotask, you can run any kind of custom logic. You can also access external APIs. And for that, what you can also do is you can define secrets within your autotasks. And these are values that you can access from your autotask code without having to hard code them on the code. These are again stored on a secure vault, and they are made available on runtime when you run your autotasks. Okay. A sneak peek of some things that we're working on relayers. We're working on policies. So when you set up your relayer, you can restrict it so that you can only send certain number of transactions or certain number of funds or hit certain contracts as a whitelist, so that if your API key and secrets get compromised, then you still limit the surface area of what an attacker can do by having control of your relayer. And we're also, in the scope of relayers, working on adding support for more networks as well as we get new requests from our users. But okay, with that said, we'll go on to the next component, which is Sentinels. Sentinels is the component of Defender that works for monitoring contracts. So you can define any kind of conditions on contracts that you want to monitor. And Sentinels will alert you via email, Slack, Discord, Telegram, will send the data to Datadog for further analysis, and will even invoke Autotask in response to that. So you can define any kind of transactions that you want to be alerted upon on your contracts, and you'll not just get a notification on them, but will also be able to run any kind of code to react to them. And this code can even send a transaction to immediately respond to whatever happened on your contract. So as an example, what we're going to do is we're going to monitor all calls to the deposit vault contract. Actually, no, we're going to monitor deposits that are significant in amount. we're going to trigger a Sentinel in that case, and we're going to call the sweep tokens function, the autotask that we have just defined, that takes care of sending a transaction via the relayer to move the funds out of the vault contract. So the idea is whenever there is a big deposit here, we'll get notified by Sentinels, which will trigger our logic from autotasks that sends a transaction via relayer to move those funds elsewhere. So let's put all of the pieces together. Going to go ahead and create a new Sentinel for monitoring vault deposits on RinkBuy. This is going to happen on the vault contract. Again, we're getting the API from Etherscan, and we're going to run this as soon as there is one confirmation block. We can also decide to wait a few more blocks for confirmations in case we want to be more resilient to reorgs. And here we can define what are we interested in and what kind of filters we want to set. For instance, we could filter transactions where gas price is greater than 110 gigaways, and where the status of the transaction has been successful, or any other kind of logic. We're not going to go with that. We're just going to go monitor deposit events and where the fee was greater than, I don't know, 10,000 wei. It's not that much, I know, but here we can set up any kind of conditions we want based on transaction parameters, also the arguments of the events that were fired, or that the functions that were called on the contract. I'm going to go ahead, and here we configure what we want to happen when a transaction that matches those conditions is seen on the blockchain. So we're going to send an email and trigger Slack webhook, and we're also going to trigger the sweep tokens autotask in response to that. We can also choose this only to be executed. Let's say if these transactions appear 10 times within 15 minutes. This is super useful for getting alerts on high failure rate, for instance. And we'll also set up a window between subsequent notifications in case we want to limit spam. Okay, we're going to go ahead and create the Sentinel. Okay, so we got vault deposits running. And we're going to go ahead and run a deposit. Actually, we're going to run it directly from the relay I had just created. I'm going to send a transaction from here onto the vault contract. I'm going to call deposit with a little bit of if. I'm going to prepare a transaction and send it via the relayer. And so this is going to use the relay I have just set up for sending the funds. And by the way, we do auto-funding of relayers, of testnet relayers. So if you set up your relay on RinkBuy or Girly, we'll automatically send one test it so you can start working with it right away. For mainnet relayers, you have to fund the relay addresses yourself. We'll send you a notification upon low funds. And we're also working on features for having a central funding account. So in case you have several relayers on the same network, you can send your funds to a single address, and from there we take funds to every relayer as needed. Okay, so we have the deposit transaction sent. If we see it was sent from 380CF, which corresponds to the relayer that we have just created. Again, the private key for this relayer is managed by Defender and stored on secure key vault. And we should also be seeing on Slack that, 1 minute ago, we got a transaction for a deposit with fee greater than 10,000 wei, and with a link to the transaction on Etherscan that we're just viewing. And I also got an email with exactly the same information. Let me see if I can share it real quick. Just a second. Okay, the email hasn't arrived yet, so maybe gonna take, here it is. Okay, so here we got the email. Oh, I have more, it's funny, I have more than one Sentinel configured. So if you see here, it's value over 100. This is from an older Sentinel I had set up. Okay, so here we get the link to a transaction that was picked up by the Sentinel. I got the alert via email. And last but not least, if we go to Autotask on the sweep token function, what we should be able to see is that there should be an execution triggered by a Sentinel that took care of moving these funds out here. It's sweeping these funds, which corresponds to the fee we sent, out of the contract or transaction sent by the relayer. So effectively what we have done is, as soon as a deposit came into the contract that could have sent by a user or anyone, we trigger a Sentinel that alerted us via email and Slack, and trigger an auto task with our custom logic for sending a sweep transaction via relayer to move the funds elsewhere. So with this, you can set up any kind of workflows for reacting both manually or automatically to any kind of suspicious transaction or significant transaction on your contracts. And let's say, so for instance, let's say if you see a transaction that's draining funds out of your contract or doing something that shouldn't be doing, you could use autotask and relayers to automatically pause your contract and then use admin for either unpausing or scheduling an upgrade that fixes the issue and easily approve it using your multi-sig wallets. Okay, the last bit we have to share in Defender is Advisor. Advisor is a knowledge base with best practices, with security best practices that we have been collecting throughout the years. We share best practices for development of smart contracts, also testing, monitoring, and operations. Each control is rated and also has a level of effort associated to it. And the idea is that when you're developing your system, you can search here for any kind of topic you're concerned about, let's say reentrancy, and you can get a list of related articles to that explain what reentrancy is about in this case. You have links to previous instances of these attacks, what patterns you can implement to protect against it, which code snippets you can use, some examples, either vanilla example or in different contexts. And you can basically rely on this for getting better knowledge on what kind of security considerations you need to take into account when developing your system. This doesn't remove the need for an audit, but it can certainly help in guiding you through what kind of things you should be aware of when building your system. We're constantly adding new material here. The idea is to make it as a knowledge base that you can check at any time. Okay, that's it for today's demo. Again, make sure to check out the documentation. You'll get docs not just on Defender, but also you can get documentation, as Jonathan was mentioning, on contracts and all of our offering. You can get here reference on the API in case you want to programmatically interact with Defender and make it part of your CI and CD pipeline. And you can also get into the community forum where we have a dedicated Defender section where you can ask any questions you may have, share things that you have building, or whatever you want with the rest of the OpenZeppelin community. Okay, so that's it. Not sure if we have any questions.